Okay, we're going to talk about parallelograms, okay? We're in the section of quadrilaterals, right? Which is a polygon with how many sides? Of course, 4. Okay, parallelogram is a quadrilateral with both pairs of opposite sides being parallel, okay? The symbol for representing a parallelogram is a parallelogram symbol, like that. Man, that's ugly. Okay, oh God! Okay, like this one right here would be parallelogram real, okay, where you would say parallelogram real. All right, so there's 6 qualities, 1, 2, 3, 4, 5, 6 qualities for a parallelogram that are true. Okay, the opposite sides are parallel, of course. It's a parallelogram. So both pairs of opposite sides are parallel, okay? So you could say that RE is parallel to AL, you know the symbol for parallel, right? And then RA is parallel to EL. Okay, all of those are segments. And next, the opposite sides are also congruent. Of course, they're the same length. This one's congruent to this one, and this one is congruent to this one, but they're not the same, all 4, the same length. So ME is congruent to AL, and MA, Ma is congruent to EL. Okay. Another quality is that the opposite angles are congruent as well. Don't they look congruent? Like angle D is congruent to angle L, and angle A is congruent to angle E. They're all, the opposite angles are congruent. Okay, so D and L are congruent, and A and E. So that's 3 qualities of a parallelogram. Okay, consecutive angles are supplementary. Okay, if you have 2 in a row, they're supplementary. Like this one, if it was 100, this one would be 80. Okay, we know that opposite angles are congruent, right? So they're 80 and 80, right? And this is 100 and 100. Well, notice how the ones next to each other are all adding up to 180, right? So here's 2 examples. There's 4. The measure of angle V and the measure of angle A add up to 180, right? Okay, and then pick 2 more. Let's say the measure of angle V is also, along with angle E, going to add up to 180 as well. Okay, so these are all adding up to 180. They're supplementary. Okay, each diagonal, okay, separates a parallelogram into 2 congruent triangles. In other words, that triangle and this triangle are the same size. So AZE is congruent to ELA. Okay? And then the diagonals bisect each other. They cut each other in half. Okay? So Texas is congruent to extra large. TX is congruent to XL. Okay? And AX is congruent to EX. I'm not going to say ax the X, that wouldn't be good. Okay, so these 2 would be congruent. So this one and this one are congruent, and this one and this one are congruent, but they're not all 4 the same length, because this diagonal here is longer than this diagonal here. This one's short, okay? I usually show it with I've got a parallelogram in my class made out of wood, but you know, I'm not going to show you here. Just, you know, you can kind of tell that that's short and that one's longer. Okay, next page. Okay, so in this parallelogram it says that we got to label everything. Okay, LM, where's that at? Down here. That's 86. LK is 100. JML is this angle right here. JML, right? M is in the middle, right? So we would put angle 62. Okay, so that's for that whole angle right there. Okay, so JO is 5. MK, where are you? MK is this whole length, which is 15. So I'll do this or something. Okay, so this one is 15, and it says find all these measures. Okay, so JM is this one, so it's got to be the same as this one, so that's 100. Okay, B, angle KJM. Okay, KJM, J's in the middle, so that's this angle right here. Well, how do we find it? Well, these two angles would be supplementary, right? Because consecutive angles are supplementary, so you'd say 180 minus the 62, and that'd give you 118. So this big angle right here is 118. That's all the whole big angle, the J in the corner. They're MJK. All right, so that's 118. Okay, KJ. Where are you? There's K, there's J. Okay, so if that one is 86 down here, that's got to be 86 up there. Okay, LKJ. Okay, LKJ. That's the one in this corner. Okay, that's this green angle right there. What size is the green one? Well, same as this one, right? 62. So that would be 62 degrees. Or you could say these two are supplementary, so 180 minus 118 will give you 62, whichever. MLK, we just had that day the other day. Cool. Okay, so MLK would be, got green again. Okay, so that one in that corner is MLK, and it would be the same size as this one, right? 118, so this one would be 118 as well. So for MLK, I'm going to put 118, and then for OL, that's this one. It's 5 up here, so it's got to be 5 down here because diagonals bisect each other. Okay, JL is the whole length, so that 5 and 5 is 10. OK is this one. OK is this one. Half of 15. Good grief, I'm slow today. It's Monday. Okay, so that's 7.5. All right. These angles, okay, obviously Z would be 115 because opposite angles are congruent. This is like a transversal, right? So these are alternate interior angles, so that would be 30 degrees for Y. And then how would you find X? Well, that's 115. All three angles would add up to 180, so 115 and 30 is 145. Subtract from 180 and you get 35. So this one's 35, okay? Number 3, these two, are they supplementary or congruent? They're supplementary. Remember, these are consecutive angles. I didn't really ever talk about it, but aren't they consecutive interior? Well, sure. Okay, so 4x plus 7x plus 15 is equal to 180, and then you solve. Okay, that's 11x plus 15 equals to 180. Subtract 15 from both sides, so that's 165. Is equal to 11x, and then I think that's, what is that, 15? 5, oh God, that feels so slow. Okay, so that's 111, so that's 55, so yeah, it was 15 all along. Okay, I'm just making sure. Okay, x is 15, so you plug back in to get angle A, so 4 times 15 is 60. Okay, you know angle C is going to be 60 because opposite angles are congruent. And then really, this is 120, right? I don't even have to plug in if I don't want to. That's 120, and this one's going to be 120, right? So these two are 120, 120. They're all degrees. They're all angles. Yay. Okay, next, based on this picture, it says find AE. Okay, that's this one, so I'd have to know why. So these are congruent because they bisect each other, right? So they're congruent, so you'd set them equal to each other. So y plus 10 equals to 6y. Okay, get rid of the smallest y. Okay, that's gone. 10 is equal to 5y. Divide by 5, and you get y is equal to 2. Okay, so if I want AE, I plug in here. 2 plus 10 is 12. Okay, AC. AC is the whole length, so it'd have to be twice as big as 12, right? Because these are the same. Like if this one's 12 and this one would be 12, then that's 24 for AC for the whole length. Because diagonals bisect each other. Okay, the intersection of the diagonals. Okay, so if you have parallelogram A, B, C, D, it goes around in order. And A is 2, 5, and B is 6, 6, and C is 4, 0. The best thing to do is just to always draw it out. Okay, and 0, -1. Seems like a pain, but it helps you to solve it. Okay, so they want to know what this intersection point is right here. Well, isn't it halfway between these two and halfway between these two? So it's a midpoint, right? So what is the midpoint of this? Well, you would just do the midpoint formula, right? Where you'd add the x's up, 2 plus 5, I mean, or no, 2 plus 4, excuse me, divided by 2, so that's 6 over 2, which is 3. And then you want to do the y's, that's 5 plus 0, 5 plus 0 divided by 2, so I'm adding the y's, that's 5 over 2, which is 2.5. Okay, so the midpoint, this one is 2.5. Last page. Now this is a little bit different because this is starting out with a four-sided shape, quadrilateral, and seeing if it's a parallelogram. Before we knew it was, okay? But now we're seeing if it is, and there's tests for that, okay? There's 1, 2, 3, 4, 5 tests, and the first 4 are very, very, very basic because they're exactly what the rules are for parallelograms, okay? So those 4 are easy. Now this last one's weird. A pair of opposite sides is both parallel and congruent, okay? So this one says if both pairs of opposite sides are parallel, okay? So if this one and this one are parallel and this one and this one are parallel, then guess what? The four-sided shape is a parallelogram, okay? So if this one has opposite sides that are congruent and you find that out, then you say, oh, well, it's got to be a parallelogram, okay? Because of this reason number 2. Okay, number 3, if both sets of angles are congruent, then, oh, it's a parallelogram, okay? The diagonals bisect each other. If you find out that this one was 5 and this one was 5 and this was 7 and this was 7, then yes, it's a parallelogram because the diagonals bisected each other. But this one's weird. Okay, number 5, it says a pair of opposite sides is both parallel and congruent. And that one proves it as well. It actually proves that that a four-sided shape is a parallelogram. Okay, so let's look at these, okay? So is this a parallelogram? It's got kite qualities because of the consecutive congruent ones, but these are not opposite sides that are parallel or congruent, okay? So this is a no. All right, none of those fit, okay? So this one has parallel and congruent for the same set of opposite sides. So which one is that? Yes, it's that one, okay? It's the reason number 5, so it's reason number 5. Okay, this one, both sets of opposite sides are parallel, yes. Okay, which one is that? Okay, parallel, that's number 1. So by reason number 1, this is a parallelogram. Okay, here, okay, they're talking about bisecting, you know, like this, diagonals bisected each other, but it didn't talk about these, did it? Okay, and then it gives you an opposite sides that are congruent, so it didn't fit any of those, so it's a no. That's not a parallelogram. It's just a quadrilateral at this point. And then this last one is kind of silly. They want to prove that this four-sided shape is a parallelogram by figuring out what x is. And for that value of x, it's going to be a parallelogram, okay? So if these two are congruent, they're already, one of them's parallel. So we're basing off of this idea, right? Okay, so if you set these equal to each other, 4x minus 1 is equal to 3 parentheses x plus 2. If you solve for x and you find out what x is, then it's going to be a parallelogram if for that one value of x, obviously, because these opposite sides are parallel and congruent, because you're proving that they'll also be congruent as well, and that would fit number 5. All right, so let's solve. Okay, so that's 3x, and then 3 times 2 is 6. Make sure you do the second one. Everybody forgets that one. Okay, so that's 4x minus 1. Get rid of the smallest x. Okay, and that's gone. And then you got x minus 1 is equal to 6. Add 1 to both sides. That's gone. X is equal to 7. So for this value, x, if it's 7, then it's a parallelogram. Okay? Yay, we're done. Have a good day. Okay, one more side. Basically, this problem would have been for you. You just set them equal to each other, right? And solve, and then whatever m is, we'll make this a parallelogram. Okay? So this is 3m plus 8. Subtract 3m from both sides. Well, whatever. The answer is m is equal to 6. Okay, I'm not worried about that. So that makes these congruent and parallel. So by rule number 5, it's a parallelogram. Okay, this is what I want to talk about, this coordinate geometry. Okay, so we're trying to prove that this is a parallelogram. And usually parallelograms, you would prove that the opposite sides are parallel. Okay, so slope. Okay, we want to know the slope of this one and this one. Okay, those opposite sides should have the same slope for it to be parallel, right? So this is up 3 and over 2. Remember, you start from the left side and go up and over. Okay, so that's 3, 2, so the slope is 3 over 2. Okay, now does this have the same slope? Don't let it bother you to go inside. It's okay. So go up 3 and over 2. You start from the left, go up or down, right? Remember? Okay, even kind of looks cool because of it looks like a 3D shape. I know I said that before. Okay, so that's 3 and 2. So this is 3 over 2. So these two sides are parallel, right? Because they have the same slope, right? Okay, the green sides should be parallel as well if it's going to be a parallelogram. So this one, you start from the left like always, and you don't go up and over, you'd have to go down and over. Now if you go down, it's negative, right? So you go down 1, and then what is that? 1, 2, 3, 4 to the right, okay? So that would be negative 1/4 for the slope, right? And then this one should be a negative 1/4 as well. Remember, you start from the left, go down and over, okay? Down 1, which is a negative 1. You can't see that, but just know it's there. That's a negative 1, and that's 4 this way. So negative 1/4, okay, is the slope of this one, okay? All right, so these are parallel, and if both pairs of opposite sides are parallel, then ABCD is a parallelogram. Yay! Okay. And while I'm at it, let's talk about length or distance. What is the length of the two pink sides? Okay, AB, how long is it? What is the distance? Right? These are slope, right? This is distance. Okay, remember we used the adding Pythagorean theorem, and if we want to, we can just, let me just do this here, make a bunch of right triangles all the way around. Okay, so this right triangle is a 3, 2. This one's a 1, 4. It's not a negative 1, 4. Distance is 1, right? You do just, that's a 1, 4. This one is a 3 and a 2, right? And then this is a 1 and a 4. Let me put those numbers on there. That's a 1 and that's a 4, just like that's a 1. Just a 1 because it's not slope. We're just talking about how far it is. Okay, so that's 1, 4. And then this one's a 2 and a 3. So you've got AB, which is this one, right, is a square root of 2 squared plus 3 squared, right? Remember? Okay, so that's something. 9 square root of 13 is, I don't know, 3 something. Okay, and then the other one should be the same thing, which is, what are those letters? The D and a C. So that's DC, and that one's a 2 squared plus 3 squared, right? Because it uses a 2, 3 right triangle. This one's a 2, 3 right triangle, and then the other two, AD, it's hardest thing is to find the letters. AD and then BC, right? So those two should have the same distance as well. Okay, so those are 4, 1, 4, 1. Okay, so that's 4 squared plus 1 squared, and 4 squared plus 1 squared. I don't have a calculator, but I know that's a little bit more than 4. Okay, so this is a little bit less than 4. So these two are the same length, and these two are the same length. Okay, so the opposite sides are congruent as well, which it should be. Anyway, I just wanted to show you this in comparison. All right, very good. Have a good day.